Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the different methods which are used for developing a layer of the suitable material in form of coatings, weld overlays, so that the surface properties can be enhanced for improving the tribological life of the components. So, under the different thermal spray processes, we have talked about the high velocity oxy-fuel spray, detonation spray, flame spray processes. In this presentation, we will be taking up the three thermal spray processes. These are like cold spray, arc spray and the plasma spray processes. Now, if we see in the case of the cold spray, why this process is called cold spray? Because it primarily uses the hot gases for heating purpose. It uses the hot gases for heating the material, like so. There is a heater which is used for heating the gases, and this heating is performed means hot gases of the temperature like 300 to 400 degrees centigrade hot gases are used, and in addition to this, high pressure gas is also used. And so, the high pressure gas which is at a high temperature of 300 to 400 degrees centigrade is fed to the gun. Now, this gun is made of the typical geometry like this, which is basically converging and diverging, and this converging diverging nozzle helps to accelerate the gases, so that these attain very high velocity in the range of 500 to 1500 meter per second. So, such a high velocity helps the particles also to move at a higher velocity. So, if we see high velocity of the gases helps to move the particles at a high velocity during the spraying. If we see this schematic, then these gases are also used to feed the material to be coated through the suitable powder feeder. So, the high pressure hot gases and the material to be coated is fed from the feeder to the nozzle gun, where the converging diverging design of the nozzle helps to accelerate the hot gases, and along with that powder particles are also accelerated to the high velocity, and their impact with the substrate helps to develop the coating. So, if you see, this process is characterized as a very high kinetic energy coating process, because the particles attain really very high velocity, 500 to 1500 meter per second, and the rise in temperature of the particle is also not high, as the gas temperature, the hot gas temperature is limited to 300 to 400 degrees centigrade. So, if we see the particles which have not been heated to much higher temperature, when they are accelerated to very high velocity, after the impact they get flattened. So, the flattening actually happens in the solid state itself, and this leads to the plastic deformation of the powder particles while flattening, and this causes the plastic strain in the material which is being deposited in form of the powder particles. So, this plastic strain eventually results in the development of the residual compressive stresses. If we see, the material powder particles are just being heated, there is no melting, and since the rise in temperature of the powder particle is very limited, so absence of the melting, and also there is no oxidation of the material which is to be coated in, and there is no undesirable metallurgical transformation. So these are the some of the benefits. At the same time, there is no, since there is no melting, so there is no solidification as well, and accordingly the no solidification related defects. So because of these very positive features associated with this process, this process is found extremely suitable for the materials which have the tendency to get degrade due to the high temperature in case of the other thermal spray processes. And because of this, we find that the kind of the quality of the cold spray coatings is much better as compared to the other processes, as there is no melting, no oxidation, no undesirable metallurgical transformation, and no defects associated with the solidification. In addition to this, we have one more advantage in this process, that is like whatever powder particles are being accelerated at a high velocity, and after impact they will be getting flattened. So if they are having any of the impurities or oxide layer on its surface, these brittle oxide layers, due to the plastic straining deformation after the impact, this is broken down. So breaking of the oxide layer, basically the fracturing or breaking of the oxide layer takes place, and which leads to the deposition of the clean material. So this we can say the self cleaning of the powder particle is inherent in this process, and similarly the other powder particles which will be impacting with the substrate or already deposited the material, there will be, due to the removal of such impurities and oxide particles, there will be direct contact between the various particles, direct metal to metal contact. So what we say, direct metal to metal contact is established, and which results in very good bonding between them even in the solid state. Since in this case there is no melting, so there is no metallurgical bonding in the initial stages. Bonding is primarily caused by the mechanical interlocking between the coating material, and the substrate. So what is the meaning of interlocking? That if the irregularities are present at the surface, then the particles will also get flattened with the, and they will get deformed, means all these peaks and valleys will get deformed and get mechanically interlocked like this. So the presence of irregularities, at the same time the plastic deformation of these irregularities is important for mechanical interlocking of the material which is being deposited. So the prerequisite for development of the coating substrate bonding is the ability of the material to get plastically deformed, plastic deformation tendency, and this one is needed in both the material to be deposited in coating in form of coating and also the substrate. And therefore the coating materials which are comparatively soft like aluminum, magnesium, zinc, titanium, stainless steel, etc., coating of these materials can be effectively easily deposited without any without thermal damage. While this little bit ductility or the ability to get deformed is also needed in case of the substrates. So, substrates which have the reasonable ductility can be coated with this process. So, some amount of the ductility with the coating material as well as substrate material is required, so that the surface layer deformation can be facilitated to ensure good mechanical interlocking between the coating and the substrate, so that the good bond strength can be realized. So, as far as the cold spray process is concerned, there are very few advantages associated with this. One is that there is no melting due to the low temperature. Temperature is limited to 300 to 400 degree centigrade. No solidification in this process. There is no thermal damage to both substrate as well as coating material. So, absence of thermal damage will be leading to the no distortion tendency and no undesirable metallurgical transformation. So, these are few extremely favorable points associated with this. At the same time, it also offers the advantage of the self cleaning of the substrate as well as powder particles due to the kind of the plastic strain which is associated with the impact of the high kinetic energy powder particles at the surface of the substrate. At the same time, the requirement of the surface preparation like shot blasting, shot pinning etc. is also reduced, because impact of the particles at a high velocity results in the good mechanical interlocking. So, in addition to this, one very favorable point associated with the thermal spray process is the development of the residual compressive stresses, because whenever material gets flattened plastically like this, so part of the material will be placed under the plastic strain and then elastic strain. So, the elastic strain portion tends to get back in its original position, and that is restricted by the firm mechanical interlocking with the substrate, and that is why we get the residual compressive stresses in the substrate itself. So, these are few very favorable points as far as cold spray is concerned. Apart from this, there are few limitations associated with this process also, like the very hard and brittle coating materials as well as substrate material are difficult to develop the coatings by this process. So, the coating materials or the substrate materials which are extremely hard and brittle and show the very limited ductility, it is found difficult to develop the coatings using this process. So, indirectly we can say the process is limited to the soft and ductile material. At the same time, the process is bit costly and expensive, because the high pressure gas consumption associated with this process is very high, and that is why the application of this process is limited to those metal systems which cannot be deposited using conventional thermal spray processes like the detonation gun or HVOF or the plasma arc spray process. So, this is one, and it may be in form of like if there will be significant improvement in performance of the material, if there is no oxidation is required or needed for excellent performance, then the materials are coated using the cold spray process. Now, we will talk about the another spray process, that is the arc spray process. So, this arc spray process where the material may be in form of the filler or filler wire or powder. Basically, this process uses the heat generated by electric arc. So, electric arc is heat of the electric arc, which we can say the power of arc is given by Vi. So, Vi decides the amount of the heat being generated. Mostly this process uses the two wires like this. So, one is and these wires both are both are consumable electrodes of the material to be coated. So, like if the zinc is to be coated, then both the wires will be made of the zinc and they are connected to the suitable power supply. So, there will be an arc is established between these two wires. So, when the arc is established between these two wires, the heat generated facilitates the melting of wires, and once the melting of the wires at the tip starts wherever arc is there. So, heat of the arc being established between the two wires facilitates the melting. So, this molten metal whatever is created needs to be transferred onto the substrate, and for this purpose high pressure air is used to atomize the molten metal drops. So, high pressure jet is used to atomize and accelerate this towards the surface of substrate. So, fine droplets of the molten metal are accelerated towards the surface of the substrate, where after impingement they get flattened in form of splats, and after the solidification they get developed in form of coating. So, basically the filler wire, the coating material is used in form of filler wire, an arc is established between them, then the molten metal is atomized with the help of the compressed air, and this after atomization the fine molten metal drops are achieved, and then these drops are accelerated towards the surface of the substrate, where these molten metal drops after the impingement will get flattened and and eventually after the solidification these will be leading to the formation of splats, and so continuous deposition of the splats on the surface of the substrate leads to the development of the coatings. So, for this purpose, since the both wires are consumed in this process, these wires need to be fed automatically during this process. Since during the arcing heat should be generated equally in both the sides of the filler wires, so that the consumption rate of both the electrodes or both the wires is same. Otherwise, if we so for this purpose only we use the AC for establishing the arc between the filler wires. So, for arc spray basically we use AC. In case of the AC, if we use DC, say this one is connected to the positive terminal and this another wire is connected to the negative terminal, and we know that if the DC is used, then the negative terminal the electrode with the positive terminal will be generating more heat. So, it will be melting at a faster rate. We need to feed it at a faster rate to maintain the arc gap or to maintain the gap between the filler wires, so that the process can continue. So, to avoid this difficulty, AC is used, because in case of AC this polarity keeps on changing after every half cycle, and therefore, the equal amount of the heat is generated both the sides of the arc, and that in turn facilitates the melting of the electrode or the wires at the same rate, and therefore, we are in position to feed both the wires at the same rate. And this kind of the process generates the temperature of the molten metal in the range of 2000 to 3000 degrees centigrade, but the velocity which is attained is moderate. It is not very high, it may be like say 50 to 100 meter per second. So, moderate velocity and the high temperature, these are the two aspects associated with this process. So, because of high temperature, there will be the tendency for thermal damage to the material which is being deposited. But since in this case the workpiece or the substrate is independent of the electric circuit, and the arcing is taking place between the two wires only. So, there is a good flexibility as far as the standoff distance between the arc spray nozzle and the substrate is concerned. So, that distance there is a flexibility with regard to the distance, and arc will not be affected with the minor variation in the distance from the spray to the workpiece surface, because the arc is established between the filler wires and workpiece is not the part of the electric circuit. So, this process is considered to be the fairly good for depositing the material at very high deposition rate. It also results in the good bond strength between coating and substrate. At the same time, since it offers a moderately higher velocity, so the porosity is also limited, because the impact of the molten metal at a moderately higher velocity leads to the good firm contact between the splats or between the molten metal and the substrate particles. So, the porosity is reduced, and all these factors are favorable as compared to the flame spray process, and this process is commonly used for depositing the metals for corrosion resistance applications. For example, if you want to deposit zinc, magnesium, then the coatings of these materials can be effectively developed with the help of the electric arc spray process. So, this is the schematic of the arc spray process, where there are two wires which are being fed through the with the help of the wire feed systems. They are rollers, and the rollers rotation will be deciding the rate at which these are being fed, and through the nozzle in control way these are fed through the guide ways, and then as soon as the arc is established between the two, the melting is facilitated and the molten metal is subsequently atomized with the help of the high pressure air or any suitable gas can be used. So, once the atomization of the molten metal takes place, these will be accelerated towards the surface of the substrate where coating is to be deposited. So, there are other thermal spray processes also like plasma spray process. Plasma spray uses the non-consumable electrode for developing the arc between the electrode and the nozzle, and the heat of the arc is used to develop the plasma. Plasma is passed to the nozzle, and wherein we feed the material to be coated onto the substrate, but the kind of temperature which is achieved in the plasma spray process and the velocities which are realized through plasma spray process are much higher, and therefore the plasma spray can be used for developing the coatings of the high temperature materials. Now I will summarize this presentation. In this presentation, basically I have talked about the two spray processes. One was the cold spray and another was the arc spray. In case of the cold spray process, only the high pressure hot gas which is heated to the 300 to 400 degree centigrade is used for achieving the reasonably high velocity, which helps in moving the particles at very high velocity, and the particles during the spray remain in the solid state. There is no melting, and the process because of the high velocity impact with the substrate remains the self cleaning in nature for the substrate as well as the coating powder particles. And apart from this, high velocity powder particles spraying in the solid state facilitates the development of the residual compressive stresses. On the other hand, wire arc spray process basically uses the heat of arc for melting of the material to be coated, and this molten metal is atomized with the help of compressed gas, and subsequently after impingement with the substrate, solidification facilitates in the development of the coatings. So, the arc spray offers the much better coating characteristics as compared to the flame spray processes. Thank you for your attention.